We have the integral from 0 to 2/3 of the square root of 4 minus 9x squared dx. You probably know what's coming, don't you? Please pause the video and see if you can finish this. Just checking to see if we're on the right track here. Since the radical has 4 minus 9x squared inside of it, the variable is second, and so I'm going to be using the sine function. Setting up my right triangle, I have the acute angle opposite which is 3x. The hypotenuse is 2. So the sine of theta is 3x over 2. So x is equal to 2/3 times the sine of theta. From that I get that dx is 2/3 times the cosine of theta d theta. Going back to the triangle, the cosine of theta is equal to the square root of 4 minus 9x squared divided by 2, which I underlined, it didn't mean to. The square root then of 4 minus 9x squared is equal to 2 times the cosine of theta. That's what I want to underline. We need to replace the square root. We need to replace the dx in the radical. And we need to change the limits of integration. Let's talk about the limits of integration. X goes from 0 to 2/3, and theta is kind of wrapped up in this substitution for the sine function. If x is 2/3, then we know that 2/3 is equal to 2/3 times the sine of theta because of our substitution. Therefore, the sine of theta is equal to 1, and theta must equal pi over 2. If x is 0, then 0 is equal to 2/3 times the sine of theta, and so theta is equal to 0. Our integral then becomes the integral from 0 to pi over 2 of 2 times the cosine of theta, that's the replacement for the square root, times 2/3 times the cosine of theta d theta, that's the replacement for dx. And we've replaced everything we need to for the integral. Question: where did x equals 2/3 sine of theta go? Well, we didn't have a factor of x in the integrand, and so we didn't need to directly use that. Where we used that was in finding our dx. If you got this far and you were correct and continued on, cool, just keep watching. Otherwise, let this be just a way to make sure you're on track, and then let's go ahead and finish out the problem now. Pause it and then finish out the problem. Multiplying 2 by 2/3 gives us a 4/3 that I'm writing as a constant outside of our integral. Cosine times cosine is, of course, cosine squared. Using a power reducing formula, we cut the 4/3 in half, so 2/3, and then we have times 1 plus the cosine of 2 theta d theta, that's evaluated from 0 to pi over 2. Integrating then will give us 2/3 times the quantity of theta plus 1/2 times the sine of 2 theta from 0 to pi over 2. Putting either 0 or pi over 2 into the sine of 2 theta will zero that out. So we end up with 2/3 times pi over 2, or pi over 3. Now this worked out nicely because we had limits of integration. But if we didn't, and our answer turned out to be theta plus 1/2 times the sine of 2 theta plus c, that's in terms of theta, we would need our answer to be in terms of the original variable x. For that, what I would do is refer back to the triangle. What we need to do is we need to replace theta, and we would need to replace the sine of 2 theta, both to be in terms of x. The easiest expression for theta would be that it is the inverse sine of 3x over 2. So theta would be the inverse sine of 3x over 2. And I just realized that our answer would have had a 2/3 in front of it. That's not going to change because of what we're doing now, so I don't want to be confusing there. I notice we have sine of 2 theta in our answer. We do not have a 2 theta over here in our triangle. However, we know that the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. Therefore, plus 1/2 sine of 2 theta, the 1/2 would offset the 2. Sine of 2 theta would be 3x over 2. Cosine of theta, did I say sine of 2 theta? I meant sine of theta would be 3x over 2. Cosine of theta would be the square root of 4 minus 9x squared over 2. And then plus c would basically finish this off. You might simplify it by distributing the 2/3 if you wanted to. We would certainly combine 3x over 2 and the square root of 4 minus 9x squared over 2 into one fraction. My point here is, if my answer is in terms of theta and I need it to be in terms of x, I'm going to go back to the triangle